Next is variation of resistance with temperature. There are different curves for different materials, in which the first material we have is a metal body. Resistance of the metal body will increase constantly or proportional to manner with the temperature, and the graph will be straight line. Resistance of the material, solid non-metals like wood and stone, is not depends on the temperature. Means the temperature coefficient alpha is equal to 0. For the semiconductors, temperature coefficient alpha is less than 0. It means it's a decreasing curve. In case of electrolyte, temperature coefficient for this electrolyte solution is again less than 0 and the curve will be decreasing. For the ionized gases, alpha is less than 0 and decreasing curve. And the last, alloys, we got a fixed or constant value of temperature coefficient alpha and which will never change with the change in temperature. One more substance with the temperature coefficient 0 is superconductor, and the graph will be on the axis. Like resistance, resistivity of a material is also depends on the temperature. Let us discuss the dependency of resistivity with different materials. And first we will take metals: iron, gold and copper. These are the pure metals, and the resistivity of these metals depends on the temperature, and the curve for these metallic objects will be like this, almost proportional to manner. Resistivity of semiconductor material like diode will not be 0 but decreasing continuously increase in temperature or with the rise in temperature. Resistivity of superconductor will be 0 for a particular value which is called critical temperature, and after that it suddenly increases as like a conductor. In the special case, if the volume of the conductor or material is same or constant, in that case resistivity of the material will be constant. For example, let us take a cylindrical conductor of length L and cross-sectional area A. Now stretch the conductor and draw up to length 2L, then the cross-sectional area become A by 2. In that case, the resistivity will be same for both the conductors because the volume of the conductor is same or constant. Material with high resistivity is generally used for energy generating device or lighting device. For example, electric bulb. Electric bulb have a high resistivity tungsten wire or a tungsten filament. High resistivity tungsten filament have a high melting point. That's why it is generally used in electric bulb to convert electrical energy into light energy. Same like electric bulb, resistivity of coil of electric heater is very high. It means the melting point of electric heating coil is also high. That's why it is used in heating devices. On behalf of resistivity, we will use several electrical equipment in the domestic and commercial circuits, like an electric fuse. The wire used in electric fuse have a high resistivity but very low melting point, which will connect in series with the domestic or commercial circuit to provide the safety. Nowadays, the miniature circuit breaker means MCB replace the electric fuse or old fuse because the operation of MCB is more easy in comparison to electric old fuses. And the last, thermistor is a device which is also used on behalf of its resistivity. Thermistors are generally used to detect very low temperature changes.